So I'm given the velocity of a car t seconds after passing a crosswalk. So I'm asked to find the car's acceleration 5 seconds later. So recall that the acceleration is the derivative of velocity. So I can take the derivative of that velocity function, and that will give me 6/4 t minus 4. And then I can plug in a 5 for that. So a of 5 is equal to 6/4 I could reduce to 3/2 times 5 minus 4. And if you put that into your calculator, you get 3.5. And then the units of that, well, the units of velocity is meters per second. And then this is per second, because it's a rate of change of that. So sometimes we write that as 3.5 meters per second squared. So it's meters per second per second. So in other words, it's speeding up. So for each additional second, it's going 3.5 meters per second faster. Okay. So the next one says to compute the car's distance from the crosswalk. So this is going to involve an integral, because recall that if we have the position function, the derivative of the position function is a velocity function. So I'm given a velocity function, I need to go backwards to position. So that's going to be, I'm going to do that by doing an integral. So the integral from 0 to 5 of 3/4 t squared minus 4t plus 6 dt. And so if I integrate that, that will be 13/12 t cubed. So the power of t goes up by 1, and I divide by the new power, not 13, 3, excuse me. And then minus, now the power of t is going to go up 1, so it's going to be a t squared. And then 4 divided by 2 is 2, so 2t squared, plus an antiderivative of 6 is 6t, and I'm evaluating that from 0 to 5. And so if I plug in 5, 3/12 times 5 cubed minus 2 times 5 squared plus 6 times 5 minus, now I'm going to plug in 0 into everything. Well, that's just going to give me 0. And so if I get all of that, I should get 11.25. And the units of that, it's a distance, so the units of that are just meters. The next one says, a boat leaves a dock at 4 p.m. and travels due south at a speed of 20 kilometers per hour. Another boat has been heading due east at 10 kilometers per hour and reaches the same dock at 5 p.m. At what time are the two boats closest together? So one thing we want to notice here is that I'm looking for a minimum distance. So I'm trying to minimize distance. So this is actually an optimization problem. And so our goal is to minimize distance. So first thing we need to do is I need an equation or a function for distance, and I need it to be in one variable. And then I'm going to take the derivative of that and find its maximum points. So if I think about the picture here, that's going to help me come up with my formula for distance. So I have a boat, so I have a dock, and then at 4 p.m. it's traveling due south. So I have a boat going that way. And then I have another boat that's heading east and reaches the same dock at 5 p.m. So another boat heading east. So this is boat A and this is boat B. Okay, and the distance, so let's let T be the time since 4 o'clock. And so then I can say that this distance from the dock to boat A is going to be 20t. And then at 4 o'clock, this boat is 10 kilometers out. So 10 minus 10t should be the distance from the dock to boat B. And so as time goes on, boat B is getting closer and closer to the dock, and when t equals 1 hour past 4 p.m., so this is going to be in hours. When t is 1 hour past 4 p.m., then the boat will be actually at the dock. Okay, so then I want this distance. So that I'll call it z. So I know that z squared is equal to z squared is equal to 10 minus 10t squared plus 20t squared. And so, yeah, so that's what I want to optimize. So if I want to find the minimum of the distance z, that's equivalent to finding the minimum of z squared, but anyway, let's just find the minimum of z. So I have z is equal to the square root of 10 minus 10t. Let's go ahead and multiply that out. So that's going to be 100 minus 10 times 10 times 2, so that'll be 200t, and then plus 100t squared, and then plus 400t squared. Okay, and so if I want to find the derivative of z, so z prime is going to be all of this stuff was going to be 1/2 times all of this plus 500t squared to the negative 1/2, and then times the derivative of the inside, which will be negative 200 plus 1000t. And if I want to set that equal to 0, let me just rearrange this just a little bit. So I'll get 2 square root of 100 minus 200t plus 500t squared, and on top I'll have negative 200 plus 1000t. And so if I solve this, I know that a fraction equals 0 whenever the top part equals 0. So I can basically just set this top equal to 0. So I can say 0 equals negative 200 plus 1000t, and subtract that over, and I get t equals 200 divided by 1,000, which is 1/5 of an hour. The question is, at what time are the two boats closest together? So it would be, well, it's 1/5 of an hour, which is equal to 12 minutes. Okay, and so 12 minutes past, well, what does T stand for? T stands for the time since 4 o'clock. So the correct answer is 4:12 p.m. The thing I didn't check, though, is I found that that's a critical point, but I didn't check that it's actually a maximum. So if I think about that's my only critical point that I have, so I can check my critical points and my endpoints. So I can say z at 0, z at 1/5, and z at 1 hour is when boat B reaches the dock. So if I plug all of those in for z, I can get values for each of those. At 0, I'm going to get, if I plug in 0, I'm going to get square root of 100, which is 10. If I plug in 1/5 in here, I'll get something approximately 8.49. And then if I plug in 1, I'm going to get 1. Let's see, if I plug in 1, I'm going to get 500 minus 200. That's 300 plus 1, 400. Square root of 400 is 20. And so this is my minimum distance. So the only possible places I could get a minimum is at my endpoints or my critical points. I only have one critical point, so that ends up being the absolute minimum. So by the extreme value theorem, I get that the correct answer is 4:12 p.m. All right, so for this one, I want to come up with a left-hand approximation on the interval from 4 to 9. Okay, and first I want to do L sub 10. Okay, so if I'm going from 4 to 9, that is a length of 5 units. And so if I break that up into 10 rectangles, I get that 5 divided by 10 is 1/2. So each rectangle is 1/2 of a unit wide. So that's my delta x is 1/2. That's the width of each interval. Okay. And then I want to plug in, so let's see here. I want to take, so my first rectangle is going to be 1/2 is the width times the height I'm going to take from the left-hand side. So R of 4 plus, the next rectangle is going to be 1/2 times R of 4.5 plus, and I keep going, and then my last rectangle is going to be 1/2 times R of. For the last rectangle, I want to go backwards from 9, back a half, so it's going to be 8.5 will be the end point of that. So I just want to write that using my summation notation. So I can say left-hand approximation with 10 rectangles is going to be equal to the sum of 1/2 R of, so basically it's going to be 4 plus 1/2 times J, and J is going to go from 0 up to 10. No, up to 9. Because when I plug in 9 for J, I'm going to get 4 plus 9/2, and that's going to equal 8.5. 4 plus 9/2, and that equals 8.5. Yeah. Okay, so so that is my left-hand sum. I can also take this and plug it into the actual value of R. It's going to look slightly messy, but okay, so I'm going to plug it in. So that's 4,950 e to the negative, oh, it's so small I can't see, 0.05, and then I'm plugging in the x value 4 plus 1/2 j over 1 plus 99 e to the negative 0.05, 4 plus 1/2 j, and then all of that is squared. So that's my answer right there. For the next one, I'm supposed to write which definite integral is approximated here. And so what I want to do is I want to think about, if I plug in these values of k, what do I get? So if I plug in k equals 0, I'm going to get 1/2 r of 5. Plus, if I keep going, the very last one I'll get is 1/2 r of, when I plug in 39, so 5 plus 39 divided by 20, so 6.95. Okay, and so this looks like an integral from 0 to 7 of r of t dt. Not 0 to 7, 5 to 7. So I'm starting at 5 and going to 7. Okay, and then it says, explain what the definite integral you wrote in part B represents in the context of the town's population. So T is the number of months, so that would be the amount the population grew from well, 5 months past January 1st, February, March, April, May, from May 2024 to July 2024. Okay, so that's it.